Our group consists of Mika Balmer, Lily Bailey, Sarah Collins, Sarah Pollock, and me. To kick things off, we'll be talking about a database that details the Seattle music scene. Next slide. Here's a little outline of what we have in store. Next slide. The initial conception for our database began as we tried to merge something fun and silly with something people could use. We decided that we had common ground as music lovers, but after seeing the demo presentations, we agreed we didn't want to recreate a streaming service. Eventually, usefulness won out, and as Sarah Collins suggested, we created something musicians could use. However, mapping all of the music industry is a colossal task, so we decided to limit it to the city we're in. But even the database that accurately represents the Seattle music scene with all its textures and complexities would be far too large a task for this assignment. From here, we set out to make a smaller representational version of this database we conceived of. Next slide. The conceptual goal for this database was to have something that would aid and facilitate the creation of music and its associated business within the city of Seattle. Through our database project, though our database project has less than the needed amount of factual information for usefulness, we have demonstrated that the information structures in this database would help facilitate these goals, given a larger amount of factual, detailed, and accurate data. Next slide. In the music scene, information can often be hard to come by, and the industry relies largely on word of mouth, personal friendships, and luck. For someone who has none of these, it can be hard to even know where to begin looking. We think that a full version of this database would alleviate some of these issues for less well-connected musicians in the city by allowing them an easy place to find people based on their role in the Seattle music scene and who they have worked with in the past. In addition to helping those with a larger barrier to entry in the Seattle music industry, we hope the database can allow venue bookers, promoters, and managers, as well as record labels, to find artists they are interested in working with. We also have gathered contact info and other supplementary information, such as gear lists from venues, to further help musicians who are visiting the city, so the database can also help non-local band managers, tour organizers look at details of the live music venues in the city. Another hope is that through allowing bands to create and maintain information about themselves in a public format, the database will allow them to gain further exposure and make it easier for managers and bookers to find and contact new music artists they are interested in. The final key issue we hope to aid in creating our database is addressed through the collocation of this information in an easily queryable format. A full version of this database might one day detail the Seattle music scene in its entirety. If it can do this to a reasonable amount of accuracy, analytics can be run to look at changes in the city's music over time, as well as allowing users to see who has played where, what labels have the most bands of a specific genre, and other questions that can be answered through statistical analysis. However, it is important to note that in many ways, the success of this database equates to how much of the Seattle music scene will buy into the goals and benefits of a resource like this. Because the more information we can gather, the more accessible we can make the Seattle music industry. Next slide. The business rules we created were based around our key entities and how we understood them interacting in the world. However, there are a few business rules that were created not because they accurately represent the world we are trying to record, but because they help facilitate and assist the flow of information within the database. The sentences that do not begin with the word each mostly exist as rules to help the creation and streamlining of our database. You can see that the latter half of the list might not be true in the real world, but exists to accurately represent entities in a useful way that promotes our objectives through the database. Okay, so now it's time to get into the nitty gritty. And for this, I will say next slide and hand it off to Mika Bomber, who will run you through our ERD.
All right, next we will be discussing our final ERD. Since the ideal users for our database are music industry professionals, our ERD includes entities helpful for information seeking and for information needs of artists, managers, and other professionals. The relationships between our tables were determined by our business rules. For example, our first business rule, each song must have one and only one primary artist and may have 0 or 1 secondary artist, created the interesting relationship that you see in our ERD. The result was 2 non-identifying relationships, the one-to-many required relationship being for the primary artist, and the optional one-to-many relationship being for the secondary artist on the song. Another business rule, reading each artist manager represents 0 to many artists, allows artist managers to find and research artists, as stated in our database objectives, regardless of their current status as an active or inactive artist manager. Our ERD represents this relationship with voluntary participation in a non-identifying relationship. Next. Within our ERD, we have key entities: record label, album, song, artist, artist management, venue, venue management, and user. These key entities dictate the core ideals and uses of our database and have been chosen in congruence with our database objectives. Next slide. Associative entities such as user favorite genres, user favorite record labels, and user favorite albums allow users to save and favorite other entities. We also included associative relationships such as record label artists to act as an intermediary between entities to allow for relationships such as record deals. The associative entity genre song creates the possibility of multiple genres for each song. We decided to connect artists to genres through their individual songs rather than to assign an artist to a genre to give an artist more freedom to change genres as their career progresses. Next slide. Now we will be discussing our database implementation and coding. We created 4 schema to organize our tables: creative works, organizations, person type, and user favorites. Each schema contains about 4 tables. For example, creative works contains albums and songs, organizations contains venues and record labels, person type contains artists and managements, and user favorites contains each of our user favorite associative tables. We did not have authority to drop the DBO schema, so it remains empty. For our computed column, we calculated the number of years active for each artist in our database using their start date and the year they stopped making music, if applicable. We chose to create this column so that a user can easily find how established an artist is in the Seattle music scene based on the number of years that artist has been a part of the community. Next slide. Here are some check constraints we added to our database. The first is the string check constraint of each user having a role, such as fan, artist, or manager, in the user table. These roles will give users different permissions and views in a future version of our database. The next check constraint is the integer check constraint of the zip code for a venue being limited to the Seattle area, as our database cares solely about the Seattle music scene. The final check constraint is the string check constraint of age restriction at each venue falling into the all ages 18 plus or 21 plus categories, as some artists prefer to play for specific audiences. For example, the Seattle Symphony may be for all ages, but Nirvana may want a more mature crowd for their shows. We created surrogate primary key identity columns for each set of IDs in our tables. For example, the artist management ID numbers are all in the 100s and the artist ID numbers are in the 200s. We chose to use surrogate keys because this practice makes data input more efficient and there is less room for human error.
Um, Now we will move on to the data import process with the wizard and I. Our data import process began with physically creating each table from the ERD on Google Sheets. We ensured that when we created these tables, both in Sheets and in our coding, that we matched our logical database design exactly in order to ensure one-to-one mapping. Data was entered onto these tables manually using primarily real-world data, but some data was also constructed either for convenience or because we thought it would be funny. For example, in the world of our database, Nirvana and Dolly Parton had a collaboration single in 1992 called Heart-Shaped Acrylics. It was a #1 hit on the Billboard 100. Each table was constructed in this way. We also created initial faux surrogate keys to provide a standard for foreign keys between tables. This helped us to ensure that our business rules were being met with our tuples. You can see an example here of our table representing record labels, either in the Seattle area or who represent Seattle-based artists. The table is created in Sheets and then exported as a CSV such that it can be read by dbeaver's data import wizard. Next slide. In order to upload the data, we imported and inputted the relevant files into the wizard. Because the columns constructed in SQL were identical to the columns constructed in Sheets, mapping was made much easier. While mapping columns, we skipped surrogate keys that had been created with the identity property in SQL, our faux surrogates in Google Sheets, in order to allow them to be machine generated. Once these surrogate keys were generated, we copied some of this data into our tables on Sheets, where they were represented as foreign keys, in order to allow us to import more tables via the wizard rather than manually. You can see an example of the mapping process here on the former. Please note that the CSV columns are mapped one-to-one with the target table in dbeaver, except the record label ID, which had been previously coded with the identity property and is thus skipped to allow machine generation. Next slide. Using the data import wizard was not feasible or reasonable for all of our tables. We have displayed here a representation of the insert and update process on our table for our users' favorite albums. As you can see, users can pick albums to favorite, and our database will then create that association, as well as mark the time it was done, notated as timestamp. We will next show you how this can look to users in our Views section.
All right, so we created two views. Our first view is favorite song details, or user favorite song is what it's named in the database. The intention with this view is to create a more human readable variation on our user favorites associative and or tables. So you can see in the output box that this view will show you the username of a particular user, their user ID, the song ID that they have favorited, as well as the song title and the artist that is associated with that song title, as well as the artist's ID. Um, this is just a way to bring more information together because in our associative entity user favorite song, you wouldn't see the artist of the song. So this allows the user or whoever's querying the database to see this more human readable information in one place. Our second view is concert details. So again, this is more human readable version of our entity artist venue event. So this allows whoever's querying the database to see the venue name, the artist name, the venue manager's name, as well as the date associated with a particular event. And this just allows you to keep track of or search for particular events and see who played where, when. And then we did use Tableau to create a couple of reports and visualizations for our data. The first report we created was a table that associates artist with genre. Due to how we structured our database, songs are associated with genre, and through that association, you're able to map the genres that an artist is associated with. So this is a visualization of that and shows how that would work in practice. And then the next visualization that we created were a couple of pie charts to kind of visualize the distribution in our database of uh, events per venue as well as record deals per label. This data allows us to see, which venues are the most popular in the Seattle scene, which ones are hosting the most events, as well as which record labels are hosting the most artists or have record deals with the most amount of artists. So that kind of allows our users, particularly artists, to see, to gauge the different venues and record labels and their popularity. And then the last report that we created for our database was genre distribution. So this just shows us the distribution of genres in the database. So which genres are most represented by songs in the database or most assigned to songs in the database. You can see that our most popular genre is rock, followed up by grunge, which feels pretty well suited to the Seattle music scene. Of course, this isn't necessarily an accurate representation of the Seattle music scene right now. It's just what is in our database at the moment. All right, and that's all we have for you.